So in 1.4, our big topic is what? Somebody want to tell me what the big topic is for 1.4?
Picturing expressions.
We are picturing expressions, okay? So that means we're going to be drawing graphs of them. Okay, so picturing which basically what you're doing, an expression doesn't have an equal sign, but remember if I put different values in for the variable, I will get different answers. And so then we can graph those answers because you put the variable you input and the variable that you got, or the answer that you got with that. So if we're looking at an expression, let's say we have x and y, okay, our expression is that you take x, 3x, and you add 5 to it. Okay, that's our expression. Okay, so every time I put a value of x in, I'm going to do this. So I'm going to write that actually above this one. Okay, now when people start this, sometimes they do this. And they actually write the rule here, and then they put it as an ordered pair here. This is the, oh, that's still y. But they put it as an ordered pair here, so it's easier to see what you graph. Okay, you don't have to do that, but if it makes it easier for you to know what you're doing when you're graphing, that's an okay way of doing it. Okay, so basically, when you go to graph, now sometimes you may have the numbers already. They may, and a lot of times we use the numbers 1, 2, 3, 4, 5. Okay, just because we're looking at sequences, we're also doing expressions where we added stuff. So we either start at 0 and then go 1, 2, 3, 4, 5, depending on what you're talking about. If 0 makes no sense, like it's a term in a sequence, 0 makes no sense. What would 0 term be? First term makes sense, but what would the 0 term be? That doesn't make any sense, so we don't usually use that. Okay, so 1, 2, 3, 4, 5. So you're using this, you're making a table that goes along with whatever situation you have. We made tables yesterday to go along with our situations. So we put that value in here. So what you really have is you have 3 times 1 plus 5. That answer is 3 plus 5, which is 8. So my point is 1, 8 that I'm going to graph. Okay, so you're just evaluating the expression when x is 1. Now I'm going to evaluate the expression when x is 2. So we go 3 times 2 plus 5, that's our expression. 3 times whatever the x is, it's 2 now. Plus 5, 6 plus 5 is 11. So our point would be the point 2, 11. And you should be able to figure out that quickly like I'm doing it. Your math skills should be up to the point where I can do 3 times 2 and get 6 and add 6 plus 5. Okay. If you did, go back and practice. I might give you some problems to do sometime if you say that. Ooh. Okay, so 3, by putting x in for 3, so I'm going to go 3 times 3 plus 5. 9 plus 5 is 14, so I have 3 and 14. Okay. Right now I'm asking you to show how you input it and then give me the answer. I don't have to show the work in between, but I would like to see this because when I look at your papers and you just put an answer there and I don't know exactly what you did. So I want you to show 3 times 1 plus 5. Right now, we're not going to continue that for very long, but right now in this section, I want you to show that just so I can make sure you're putting it in the right way, you're multiplying it correctly and all that stuff, okay? So the next one we're putting 4 in, so I'm going to go 3 times 4 plus 5. 12 plus 5 is 17. So I get 4, 17. So when x is 1, we get 8. When x is 2, we get 11. When x is 4, we get 17. Notice I'm going up by
3.
3.
I was right. My always.
So that's why we are multiplying by 3. This is the number we're adding, or our thing's going to go up by. The 5 was what I had to start out with because I had to get to 8 the first time. I had to get to that point, so 5 is where I had to start, and then I started adding 3 all the way up. Okay, so we've got 3 times 5 for the last one, plus 5. 15 plus 5 is 20. So we get 5 and 20. Again, we're adding 3 again. Our rule says we're adding 3 for each time. Now that's when these are consecutive. Notice it goes 1, 2, 3, 4, 5. As we go up to the next one in the sequence, then it's going up 3. We can't jump from 2 to 5 and it won't add those 3. Okay, so it has to be where you're just going up one at a time in your sequence. Okay, then you can see the plus 3. Otherwise, if I go up by 5 in x, you're not going to, so if let's say I did 10 right now, see, I'm jumping from 5 to 10, okay? That's going to be 3 times 10 plus 5. That's 30 plus 5, which is 35. So I got 10 and 35. That is not plus 3. That's because you made a big jump over there, okay? If you took how much this is, which is 15, and divided by how many steps you took, which is 5, it is. So this is really 15 being added per 5, which ends up being a plus 3 also. Does that make sense? Because I added 15 in the y's. When I jumped from 5 to 10, I jumped 5 spaces in the sequence. So I went up 15 in the y's when I jumped 5 spaces in the sequence. So 15 divided by 5 is the same as 3. So we are consistently going at the same rate. But you have to calculate that. That plus 3 won't match if you jump. I just want you to kind of remember that. Think about that. Okay? Because we're looking at how these are made, and I want you to see it. Multiplication is repeated addition. That's what we're doing over and over and over again. Okay? So then how do we graph these? Okay? So we're going to look at them right now because we're talking about like sequences that are only positive numbers. We are not going to, so there's some differences in how you graph. So we are going to graph only the first quadrant, which means that we're going to have an x that goes out in this direction, in the positive direction, and a y that goes up in the positive direction. We're only doing the positive coordinates right now, okay? So we're only using, this is called the first quadrant. And it's positive for x, positive for y, so that's what we know that's true in both of those, okay? You always start with 0 here, okay? Unless, no, you always start there, okay? And then you do consistent jumps. So if I'm labeling this, if I look at this, this goes 1 to 10, so I at least need 1 through 10. So I could do 2, 4, and you're drawing it as consistently as you can. I'm trying to make sure these are the same. So I could label it like that, knowing that in here is 1, in here is 3, in here is 5, in here is 7, and in here is 9. So you don't have to label every single one, but it has to be consistent. This size of 2 should be about the same as this size of 2, which should be about the same size as this as 2. Now, graph paper is way more accurate, and we'll start using graph paper to do these from now on because it makes it much more accurate. But if you're hand drawing one, it's fine. Okay. Here I'm going from 8 to 35, so I must get at least up to 36, right? Because 35. I'm doing it that way, so I'm gonna go up by 6s. Well, let's go up by 5s. 5, 10, 15, 20, 25, 30, 35. So we got 5, 10, 15, 20, 25. And these are supposed to be about the same apart. You could tell I got a little bit shorter there. I'll
15
make
to
it.
20 is really big.
Yes, it is, isn't it? Oh, well. 30, we're gonna make this one go up just a tiny bit, and we got 35. They're getting bigger as I go up, aren't they? Oh, well. Okay, so try to draw them somewhat consistently. If it's on your paper, you might want to use 5 squares, or maybe you jump 2 squares and make that 5. Then the middle point would be 2.5. Just make sure you know what's in the middle between them, okay? So you could put 5 little dashes here if you wanted to, but we're really going to approximate. So when you're doing some graphs, things I require, okay, when you are graphing, these are things I require on your graph. 1, you label the x-axis. X is always horizontal. So this horizontal axis is always going to be x. You also label the y-axis, and your y-axis is always going positive, it's vertical up. Okay, it's vertical. As we add to that, it will still be, x will still be horizontal and y will still be vertical. Okay. When you plot points, hopefully all of you know how to do this, but if you don't, we're going to watch at it. You go to the x value first, so this is 1, and you imagine a line right here for 1. That's your x value line, okay? Then I have 8, which is my y value line, so I go up to where 8 is and basically look for the line that goes there. Where that intersects is where your point is. So you go across on the x, you're going to go, it's somewhere on that line, okay? Then when you put the y in, which it's at 8, okay, so this is 8. So now I went over 1 and up 8. That gives me where my point is. So the x tells you to go in the horizontal direction, how many steps. The y tells you how many steps to go in the vertical direction. Okay. So here, 2, 11. Here's 2. Here's 11 right about here. So I'm going to just plot that point right there, because it's, if I looked at it, it's over 2 and up 11, and that's where I want to plot it. Okay. 3, 14. 3 is here. 14 is right under 15, so it's going to be right about there. When you draw ones like this that don't have graph paper, they're not always going to be perfect. Okay, just know that. So 417 is going to be about up here. I think. I'm looking at this crooked. 520 is right here. And then we go to 1035 right here. Okay. Now, if this is a sequence, if this was drawn from something that you see in a sequence, like your toothpicks, like your dots, like some of those, if it is a sequence, okay, you would not put a line between them. These are distinct points because you only have terms that are 1, 2, 3. You do not have a term 1.5. What is term 1.5? Not in a sequence. You have distinctive points that are terms. Okay? Just like if we were plotting how many classes you have and what your points are in the class or something, then, or in the classes, you only have 4 classes. You don't have 4.5 classes. You don't have 2.75 classes. You're enrolled in so many classes. Okay. You might just have 1 class. That's fine. Okay.
Or you just drop out.
Well, hopefully not.
But like, what about classes that don't count for a full point? Are we not talking credits
We're not
We're-
talking
we're
credits,
talking
we're talking
actual
how many
classes.
classes
Okay.
you have. We're not talking credits, because yes, we can have
I don't-
half the
that's just where
credits
my-
and quarters of
That's
credits.
just where my brain
Yes,
went to.
yes. Notice that these actually, because it's increasing by 3, they actually, if you put them together, they would all form a line. But we only draw the line in if we know that it's not discrete points. Okay, so you have to know what kind of things you're graphing. If they just give you 3x plus 5 and don't tell you whether it's a sequence or it's about classes or what the variable stands for, then you assume to put the line in like that. Well, you try to make it meet. And that would be the line you're graphing, because that says I can put any value of x in. Okay. So depending on your situation, what you use for x changes. And that's what we call the domain. It's a big word for saying domain is what you can use, what numbers can you use depending on 2 things. Depending on the expression, because some expressions you can't use all numbers, and the situation. Okay, so a domain is what numbers can you put in for x, basically, for x. I'll put use for x. Depending on the expression, we should just say expression, and the situation. Okay, we're going to talk about several of these. So this is a domain. Now there's a lot of ways people write domains. It's really frustrating because people write them all sorts of different ways. If you can describe it, I'm fine with that. Okay, if you can describe it, that's fine with me for a domain. Okay, so looking at some domains are just whole numbers. So domains can be whole numbers. Now, whole numbers actually do include 0, but we usually know what whole numbers are. They're 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, and farther. I can go on all day. Actually, for the rest of my life, and I would never go to the next number. I probably wouldn't know how to say it, but I could count up to it.
Septemvigilantillion.
Yeah, something like that, yeah. There is a sept something.
How many
Vingilantillion.
zeros is that? I think like 80 something.
There's a Google.
Yeah, Google has
Yeah.
100 zeros.
Yes,
Yeah,
it
but
does.
Kohler's number is bigger than Google.
Dang it.
Yes.
What about Googleplex? I don't think it's-
There is a Googleplex, which is bigger.
Yeah,
It's
that's
100 to 100, I think.
Yeah, that's it.
Yeah.
I remember
But
one
what was
time
1,000 zeros?
in, I think it was 4th grade, we learned about the number Google. I thought it was so cool. So I decided to write it out on a piece of paper, and then I got it done in like 5 minutes, and I was like, this is boring. I'm gonna come up with a new one. And so I thought, like, when I thought of Google, my brain went to like the browser Google.
Yes.
So I'm like, I'm gonna do one with 1,000 zeros after it, and I called it like Firefox or something.
Firefox.
It was so dumb.
I always used to call Firefox mozzarella like pizza.
Oh,
Because,
Mozilla,
yeah,
Mozilla
Mozilla
Firefox.
Firefox, so I remembered it as mozzarella. Okay.
Forever.
So you're right. We can go on forever on that, okay? Sometimes if we don't use number 1, so if you're using sequences, you actually use what are called the natural numbers. And this is, okay, I'm gonna help you remember these. Okay, the natural numbers, when we start to count, they are also called the counting numbers, which makes sense. When we start counting, we start at 1 and then go to 2, 3, 4, 5. You do not ever start with a student or a little child and say, okay, we're going to count today. We're going to start with 0, 1, 2, 3. You just wouldn't do that. Okay, so counting numbers, this one is easier. When you say natural, this is how you naturally count. You naturally count 1, 2, 3, 4, 5. So this is a way of remembering it. It's the natural way to count. The whole numbers are those natural numbers, but they include only one extra number, the 0. But what does a 0 look like? It looks like a hole. Imaginative, that looks like a hole. So the whole numbers, I was talking like this, the whole numbers have 0 plus the counting numbers or natural numbers, okay? So it's 0, 1, 2, 3, 4. So that's the only difference there. And so to me, whole gives me that idea that there's a hole, so I have to draw the picture of a hole, and that's my 0, and so that's what's included in whole numbers, okay? Now, whole numbers are not going to include negatives. They only include positives. Does anybody know when I put the negatives in what that's called? What type of numbers those are called? Yes.
Integers.
Integers. Okay, so the next one are integers. And I would say with whole numbers, a lot of these are real life situations. Because when we talk about selling adult tickets, we never have negative numbers. When you talk about selling or business, you don't have negative
Because
numbers.
that means the business has to pay the customer.
It's correct, and that would be ridiculous. Yeah. So,
But if you go bankrupt, then technically doesn't that mean?
yeah, but we're not talking, that's
So
different.
we could use Toys R Us as an example. I don't know, that's where my brain.
Yes, that is true. We do use-
Toys R Us,
We do use negatives when we're talking about banking accounts. So when you're talking money banking accounts, but not when you're selling. Okay, so selling is all positive. Usually when we talk about the number of people, which number of people can be used a lot, we talk about not negative people. That would mean you have no people. Okay, so we don't talk about that. When we talk about time, we usually really talk about positive time. Negative time is in the past. You can use it, but usually a lot of our things are not in real life. We don't go back in negative time. We start out with some money, we pay the bills, okay? We don't go back in time and say, okay, back then I had this much. No, you start right now with this money and you go in the future. You don't start to go backwards, okay? So that's something to think about, okay? So when you're looking at real life situations like time, people, quantity or price, it's usually positive. So those are some examples of things that would use the whole number. Okay, so those are examples of when we'd use the domain of whole numbers. Okay, really the natural counting numbers are when we're doing just sequences. Okay, integers are both positive and negative. I don't have anything that helps me understand what that is. I mean, I can't think of any like integers, what it means, but it's positive and negative numbers. So it's -3, -2, -1, 0. This goes out forever. 1, 2, 3, out forever. Okay, you guys gave an example. When might we use negative numbers in real life?
Use negative numbers in real life.
You gave me an example.
If I have negative.
Banks. Okay, when we're using banking, we have positive and negative. So this can be with banking. It's the money part of the banking. Okay, the money part of the banking could be negative. What's another type where we have positive and negative numbers?
Well, you can estimate how many arms you have, like if you have -1 arm or -2 arms, or if you cut off someone else's
Mason,
arm.
can you be more serious? Give me an actual
you-
answer.
negative doors if you don't have a door on the door frame.
No, okay. How would you?
That's
Negative.
zero
Negative
doors, you don't have a
You can't be
negative
negative.
door.
Well, then you have two negative doors if it's a
No,
double
you
door.
don't, that's not how you work that. Okay, yes, Ava.
Temperature.
Temperature, yes.
Oh, yeah.
We have negative temperatures. And so our input for temperature would include positive and negatives. Okay, so temperature is one. Anybody else think of another time where we use positive and negative numbers?
Stocks.
This.
Stocks go up and down. So it goes up and down. So positive, negative, if you watch that. So stock values go up and down. It's kind of like banking, but these are the values. Okay. What's another place where we
This
might
is-
use it?
Just a guess, but could you use it in population?
Yes, you can, because populations go up and down. So you give a rate and say from 1920 to 1930, the population went up by this amount. Then from 1930 to 1940, it went down so much. So again, you can do that. Yeah, so you can do population. That's correct.
Well, I'm okay.
Okay, so it can go up and down. What's another one? Yes.
The amount you earn and spend in a week.
Sure, when you earn money, that's a positive. When you spend money, that's a negative. Okay, so earning and spending money is positive and negative. There's a sport game. There's two sport games that use positive and negatives. Can you think of any sport that might use a positive and negative?
Golf.
Golf uses one. Yes, golf is our best explanation of, if you make it above par or below par. So below par is negative, above par is positive, par is zero. So it's really nice there. Okay.
Toboggan.
Toboggan. How do they use it in toboggans?
I just thought it was a funny word to say.
That's not a good example though.
Well,
Okay.
Well, I mean,
How
in the
about
Olympics,
people?
tobogganing is it uses points. So,
Yeah. Do they use positive or negative points? Or just all
Well,
positive?
you just lose points.
Oh, you
if
lose points, so you get
lose
negative.
points if you have multiple runs.
Okay,
Well,
somehow there.
okay, tobogganing is an Olympic sport.
Yeah.
Okay, let's not go into what Olympic sports are, because I could really go off on that tangent. There are some Olympic sports that I do not know.
Breakdancing.
I have one
Yeah.
actually that's serious. Coordinates.
Coordinates do, but the coordinates are usually
No.
actually shown. Oh, coordinates in life,
Coordinates.
on the earth.
Yeah.
Yeah.
like negatives
Yes,
and positives.
coordinates, whether you're up above the equator or down below the equator, whether you're to the left of whatever that is, I can't remember what it's called, but the timeline, yeah. So coordinates, I'll put GPS, how's that?
Wait, I'm curious. What's the other sport?
Football, how many yards I gained
Oh,
and how many yards I lost per play. So football does use positive and negatives. It's the season right now.
Yeah,
I know.
I watched
Yeah.
racing, like times to other people compared to other people.
Compared to other people. A lot of
I
times
was-
you can do comparisons. So if you're comparing one item to another, one's positive, one's negative, if you're above or below.
I got
Yes.
an example. For if you say time like a mile time or whatever, say
Mhm.
you shaved like 10 seconds off of it, then wouldn't
That's right, shaving
That'd be
10
nice.
seconds off. Yeah. So there are plays.
10 plus
Also, we do talk about sea level and elevation. So positive elevation is above sea level. Negative elevation is below sea level. So you want to hear one that's asked all the time? This is a prime question that is asked on cruise ships. There are many people that go on cruises to Alaska, a cruise ship to Alaska.
I did that one.
When they get up to the port, they'll ask, what sea level are we at right now? What altitude are we at right now? Now, if you're in the boat or just getting on the dock, what is your sea level?
Well, are you above the sea
Like
or are you
just
below
a
the
few
sea?
feet
A
above.
few feet above, okay? You may be 2 or 3 feet above. If you're in the ship, you may be 20 feet or 40 feet or 60 feet above.
Like still can be
Or you
underneath
break
the
it
ship,
on
under in the dump.
But if you're right there, you're at sea level.
Yeah.
Okay, technically you're at sea level right there. The dock is at pretty much sea level. Okay, but it's funny because what people think, this is where you get some of that funny things, it's farther north, right? Alaska's
Oh
north.
my gosh.
So they think they went higher because on a map, north is up.
That's so funny.
Well, your point.
So you can ask them, why do you think this would be higher than sea level?
It's
Well, it's north or it's up on the map.
What
Well,
about
that
the
doesn't
equator?
make it. Yeah.
Go up on the GPS.
This is the GPS that we're looking at, not altitude that we're talking about, okay? Or not sea
Yeah.
level or height.
If you go to
Okay.
the equator, you're higher than Alaska because that's the bulge outward.
Correct. So we're not going to go into all those details, but yes. Yes,
As like flat earthers thinking
Yes.
3D perspective.
they can't. Yes, that's true. It's somebody that can't really picture the earth as a 3D
Well,
picture.
if you go
And they are thinking that if you go up, you're going higher instead of
Well,
you're going around. You're going around.
We thought of flat Earth, that's still so
I'm just
stupid.
saying, that is a known question that people get at the Alaskan ports on cruise ships. And
They have
that's,
to explain it every time.
they
to
do
a
have to
stupid
explain,
tourist.
or they just say, I'm not gonna worry about it. Anyway, so these are different types of domains you can have. Now there's two more. There's the real numbers and there's the negative real numbers, which we are not gonna talk about right now. You're not gonna get into that till the end of this.
Negative real numbers?
Yes. So real numbers are any number you can think of. Real numbers are anything you can think of right now. They are fractions, they are decimals, they are whole numbers, they're integers. Those are real numbers. So you can get it, we can actually break it down further. I'm not gonna do that right now. Okay, so that's not something we're gonna do.
Negative 0.
That's the
Zero cannot be negative or
do
positive.
it.
Zero is never gonna be negative and it's never gonna be positive. Okay, it's just
the
zero.
exact middle point.
It's the exact middle point. Yep. So that's what you have to think of it that way. Okay. So really in this, so I'm just gonna give you an example. They have two situations here. Part A is a landscaper sells black dirt for $20 per cubic yard plus a $40 delivery fee. Let X equal the number of cubic yards. Now my question is that whole numbers, natural numbers, or integers, or real numbers, where you can use partial? This includes decimals and fractions. Okay. So, if you were looking at when you're ordering $20 cubic yard plus $40, what types of numbers do you think you could use in there? Would it be whole numbers, natural numbers, or real numbers?
For what? For
Natural
football?
numbers.
For football, he said.
Natural numbers.
Did they say
Okay.
outdoor?
A landscaper sells $20 per cubic yard of dirt.
Because you can't
Well,
have 0.
Well,
Can't really have zero.
You can't have 0 yards.
Okay, so this is actually, it's all numbers, all real numbers greater than zero. You can't have 0 yards because you're not buying anything. That would be stupid, okay? But you can have a half of cubic yard. So you would say all real numbers, that means decimal numbers larger than 0. That's how you would describe that domain.
But that's why there's different types of pricing. If I'm correct.
Sometimes, yes. Sometimes, it
Supply and
depends.
demand. Are you
Okay.
know about?
Arrangements for special dinners can be made at a restaurant. There is a $40 rental fee for a special room plus $20 per person for the food. What kind of numbers would I use there? Would I use whole numbers, natural numbers, real numbers, or integers.
Say that again.
Okay, I'm reading it again. Arrangements for special dinners can be made at a restaurant. This is when you basically reserve a room at a restaurant for a large crowd. There's a $40 rental fee plus $20 per person for the food. So the number of people is going to be what you put in. That's going to help determine your cost. So it's the number of people. What types of numbers would I use for the number of people?
I'm gonna take a wild guess, would it be sequence?
It would be a sequence, which are what kind of numbers?
Counting numbers.
Counting numbers, yes, that works. Counting are natural numbers, okay? You're not gonna count 0 people. That would be ridiculous because why would you rent it if you had 0 people? I can't even figure out why you'd pay $40 for one person to go into it. So, in real life, we'd probably say, the domain of this doesn't start until you get to maybe at least 10 people because why would you pay a $40 rental fee to rent a special room if you didn't have at least 10 people? Okay, so sometimes in real life, our situation indicates more. So I will give you one thing that is I like this because it kind of shows things for domains in real life, okay? Now, right now, we do not know how to do this, but I just want you to think about what it's representing. Okay, so if you look at a graph of insurance rates for people that are driving at certain ages. So we're using ages down here. Okay. And then it kind of goes like this. What happens as you're old, when you are very young, you don't have much experience driving. If you're a male especially, you're going to pay a lot of high rates. Okay.
So you could drive a red sports car.
And depending on what color car you drive, all sorts of different
Wait, is
things.
that actually?
Yes, that's true.
With the color?
Your insurance goes up based
If
on
you're
the
drawing a red car, yes, red are more likely to get in accidents.
Especially if it's a sport car.
Yes.
Really? That's crazy.
Just the
Oh, yeah.
color of your
That's
car?
so-
Yes.
We learned this
How?
last year, didn't we?
How is that
Yeah.
just statistically possible?
Statistically,
Red
red
is the
cars
color of
get
the race
more
car.
in wrecks than other color
What if
cars.
it's a red
Say the
Prius?
color
though?
red.
Doesn't matter.
Ah, dang it,
Now,
I
if
can
it's
see
a
that
red
car.
van, probably not, because a van doesn't get, that's the safest car that people drive is a van. So people don't get charged as much for a van or usually one of the sports utility cars, the kind of sports utilities like Subaru Outback, Subaru Foresters, Honda, I can't
What
think.
about a Toyota Prius?
So if
I'm
it's
on
a male
truck.
Toyota
driving a
Prius
red
kind of
sports
fits in
car.
that.
Okay, because that's what my parents are making me buy
So-
for my first car.
Okay, so here, I know this by a fact, at about 46 years of age is when your interest is the lowest. Okay, so that's when you basically have kids, you drive safer because you have kids. You don't go out and squirrel around as much because you have kids in the car. So 46 is about when your lowest price of your insurance will come. Then when you get older, as you get older here, it goes up again. Because older people tend to have sight problems, hearing problems.
So you're
Perspective
They go too slow. They hit things that aren't moving because they didn't see it. So they are more of a chance of getting
So
a
they're
wreck for
wrecks.
different reasons. Okay. So if you were thinking now, we're talking about ages of people driving. What do you think the domain would start at?
16?
Probably about 16.
No, probably be your
Okay.
highest point actually.
It depends on the country and the state you're in, because some places you can get a little bit
15.
younger.
15
Yes,
in Europe, I think.
15 in some places. Okay,
Let's just say
so
the US,
Well,
'cause
also
we're in the
depends-
United States.
there's places in the United States you can get it at 15.
Well,
Also,
well,
It's just say
well, you can also get
okay,
also,
state of Washington is 16.
you can get a
Okay,
license for driving on the
so
road.
at 16, we probably wouldn't go back farther. We wouldn't go to 0. I've given this to college students, and I've asked them, what does the 0 mark, how much would it cost if you drove 0? If your age was 0? And then I'd ask, does this seem practical?
Well, you will never be 0 ever.
Well, that's one thing. You would never be 0 because once you're conceived, you are starting to grow.
No,
Okay?
but like in the US, we start counting the age
When they're born. Okay, so once you're born, how many newborns go out and drive cars?
Well, it really depends.
See, in Miami.
So-
It depends if they're making.
I've given
if they
this
make
to
a money.
college students, and they'll tell me it means something when you first start driving. I'm going, it's on ages. Ages. Not on how many years you've been driving, it's on ages. What does 0 mean? What does 1 mean? What does 2 mean? Have you seen a 1-year-old driving lately?
I've seen
You
a
have.
10-year-old driving.
No,
I
I
have
actually
to.
drove a car when I was 7.
No, people do. That doesn't mean you have insurance. That doesn't mean you're doing it legally. Okay, I didn't say
I'm gonna
when
report you to the
might they
police.
drive. I'm
Yes.
saying
Oh.
when do you buy insurance? Because this is all on insurance.
There's a story of 2 kids
Oh, yeah, that's right. How long-
driving their parents' car to McDonald's and
Yes.
not getting or following all the traffic rules.
Yes. Oh, it's
Whoa.
possible, but
Like, you-
it's not legal. You should not do that. You will get in trouble. Actually, your parents get in more trouble than you do. Okay.
Wait, this is.
What do you think would be the upper age? And this one varies because it really depends. But what do you think would be the upper age when somebody's driving?
How old are
60,
you?
70,
older than 70.
Older than me. I'll guarantee that.
How old are
Older
you?
than 70.
80. How old are you? 80 max.
How old am I?
That's
Yeah.
a
I'm
rude
gonna
question,
sign up
man.
for. I'm signing up for Medicare this.
So,
Here.
so you have
I
a
don't know what
senior-
that still means.
Oh, well, ask your parents.
Do you give a senior discount?
I gave you a clue. I gave you a clue. Now you have to
She's eligible
you have-
for the senior discount.
I am definitely eligible for
So
senior
yeah,
discount.
probably older than you.
Okay.
No, I'd say 70 or older.
Have anybody ever seen a grandparent older than 70 drive?
Yes.
Yes, okay. What are some ages of some of your grandparents or
96.
great grandparents?
So,
They're dead.
96.
Do you have anybody that's nice
Actually,
that
almost-
actually
no, not
drives?
99.
Oh, wait, actually,
Well,
Now,
90.
the question is,
She was
Mason,
driving at like
Mason,
97.
listen, stop for a second.
I'm trying to think.
Does she actually drive?
Whoa. Not anymore.
Okay, so now I'm not talking about her. So what's an age of somebody you know?
My great grandpa drove to like 95.
Okay, there are people that do this.
my great
Yes.
grandpa, he's 90 something.
Okay.
He's old, but he still drives. I know
Okay.
that.
My great grandma, she's 76
Okay.
and she's still driving.
Yeah, 76 is very common. 80 is very common. When you get to 90, it slows down. But there are people up to 95 or even 100 that can still drive. They only drive during the day when it's light out. They don't drive at night. They only go short distances that they know how to get because it's harder for them to drive. But some 95-year-olds are very intuitively good, and their hearing may not be as bad or their sight may not be as bad. And so they do drive up to, so I always took, if people said 90 up to 100, I never went to 120. I'm gonna say you don't see anybody above 100 driving. I could be proved wrong if you looked on the internet and found somebody that does drive,
I would
but
add 1 year to that, and then 102 definitely not.
yeah, definitely not. So I'm just saying, when you're looking at these and when you're talking about a situation, you should think about what the domain is in the situation. This is talking about age of drivers, okay? Legal drivers in the state of Washington. They're age 16 and they can go up to about 100.
Well, there's no limit, right?
Well, again, how many do we see at 100, over 100 driving?
Well, technically there's no limit.
Do we go above 120 age limit? There's no
Wow.
limit. We don't go on forever as people in this body.
Fred Hale,
we-
113.
He did in the US?
Let me check.
Yeah,
If it's
that
not-
did not
Where's that
happen.
dog?
Well, no, his name's Fred.
No,
That's
It's
very
Stone.
American.
no, it's very German.
is, well,
Maybe German.
Frederick.
What is his last name?
Hale.
Hale,
Fred-
like
Fred sounds more
Hale.
Then
I
that's
think
so
more
American.
Europe.
what that is.
No, I think
Fred
it's
sounds